Alright, so this is 11.2 arithmetic sequences. So there's two, special types of sequences that we'll talk about, which are arithmetic and geometric. So this video is on arithmetic. When you're adding or subtracting the same number every single time, that's called an arithmetic sequence. So the recursive formula for an arithmetic sequence has two different parts, like I mentioned in the previous video. So you have the first term, okay? And then you have recursive, means I'm defining it in terms of the previous term. So the previous term, which is a sub n minus 1 plus my common difference. And I say plus, but you can still add a negative number. So you can say plus negative 2, but you're still adding a common difference each time. So show that each sequence is arithmetic, list the first term and the common difference. So here, my first term, a sub 1 equals 4. Okay, and then my common difference, so what am I adding each time? Well, I see that each time it's minus 2, so that would be my common difference. Alright, so I think the easiest way to do these is to kind of list out your terms first, because you see how easily we were able to do that in part A. So I'm going to go ahead and list out. So 4 times 1 minus 1 is 3. 4 times 2 minus 1 is 7, and then 4 times 3 minus 1 is 11, and then 15. Okay, so you can see here my first term is 3, and my difference, I'm adding 4 each time. And remember, I talked about this for a second in the previous video, but this, when you're talking about an arithmetic sequence, it's really just like a linear equation. So what you're adding each time is going to correspond to your slope. Okay, so I'm adding 4, I'm adding 4, I'm adding 4, and this would be kind of like your y-intercept. So if I subtracted 4, that would be a negative 1 there. Okay, let's do one more. So again, I think the easiest way to do it is to write out your terms first. So if we write out our terms 2 minus 3 times 1, that would be negative 1, and then negative 4, and then negative 7, and then negative 10. Okay, so a sub 1 equals negative 1, and my difference each time I'm subtracting 3. And again, you can also see that in your equation, it's written backwards, I guess you could say, from y equals mx plus b, but you can see that that's your slope. Okay? Alright, so then we have the explicit formula. Okay, so let's say I want you to find the 100th term. You probably don't want to keep adding 4, adding whatever, over and over and over again until you find the 100th term. You probably want a little bit simpler of a way to do that. Okay, so this is called the explicit formula. Okay, so we have a, and this is your first term. You can also refer to it as a sub 1, plus n minus 1. Remember, n is your term number. Okay, n minus 1, and times your common difference. Okay, so when you use this formula, it's going to enable you to find something like kind of, I think about it as like way down the road. Okay, so you could keep continuing. You should be able to get the same thing. You can keep adding 4 and adding 4, adding 4, whatever your pattern is, but this is kind of a little bit shorter of a way to do it. So this says find the 24th term of the arithmetic sequence. Alright, so the first thing I need to do is I need to find a sub 1, and I need to find my common difference. So a sub 1 is negative 3, and I notice I'm adding 3 each time. And I want to find the 24th term, so n equals 24. So all I'm going to do from this point is I'm going to plug in my values. So negative 3 plus 24 minus 1 times my common difference. Okay, so negative 3 plus 23 times 3. Okay, so when I do that on my calculator, 23 times 3 is negative 3 plus 69 is 66. And that would be my final answer. Okay, alright, next one. We have the 6th term of an arithmetic sequence is 26, the 19th term is 78. Find the first term and the common difference. Find the recursive formula, what's the nth term? Okay, so we have the 6th and the 19th. Alright, so I'm going to kind of explain the process. It's going to seem a little long, but you'll get the pattern. So we have 6, and I'm going to draw spaces all the way out to 19. It's going to be excessive, but so you get the idea. 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. So it says the 6th term is 26, the 19th term is 78. All right. So the thing we know about an arithmetic sequence, if we didn't know it was arithmetic, it'd be a lot harder, but we know that we're adding the same term each time, okay? Or we're adding the same number each time. So I have to figure out how many spaces I'm jumping. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so I'm jumping 13 spaces. Okay, so 13, I'm adding the same number 13 times. Okay, so I have to figure out what is the difference between 26 and 78. So 78 minus 26 gives me 52. Okay, so some number added 13 times gives me 52, because that's the difference between those two numbers. So you can represent that in an equation if you want. 13x equals 52. If you divide both sides by 13, x is going to equal 4. So each time you're going to add 4. Okay? So that is my common difference. If you don't believe me, okay, you can go in and fill it in. 34, 38. Doing this quickly, I hope I can add. 46, 50, 54, 58, 62, 66, 70, 74. Yes, it worked. Okay, and I would obviously go back and check yourself. Okay, so we answered one part of our question, which was find the common difference. So my common difference is 4. Okay, now we need to go back and find the first term. So 6, 5, 4, 3, 2, 1. All right, so we know to go to the right, I'm adding 4. So to go to the left to get back to my first term, I'm going to subtract 4. So this is going to be 22, 18, 14, 10, and 6. Okay, so a sub 1 equals 6. That's my first term. All right, so then the recursive formula, okay, and then the nth term would just be the explicit formula. So the recursive formula is, part of it's this a sub 1. So a sub n equals a sub n minus 1 plus 4. So the recursive formula is all this guy together. Okay. And then lastly, what is the nth term? So that would be the explicit. We're just going to write that down here. Okay, the explicit. And that's what we just did on the previous page. So let's say I wanted to find the 100th term so that I don't have to keep adding 4 every single time. So a sub n equals 6, which is my first term, plus n minus 1 times 4. Now, you can go ahead and distribute that. You should be able to recognize it, obviously, if it's distributed, if you've combined like terms. But if it just asks you to write it, then you can leave it just like that. Obviously, we don't know what n is. That's, we're trying to leave it in a general format. Okay? All right. Next, we have finding the sum of an arithmetic sequence. Okay? So there is a formula to do this. There's a couple different formulas that we can use to help us find the sum of the first terms. Okay? So the first thing that I'm asking to do, so it says find the sum of the series, and it's basically adding 1 each time all the way up to 100. Okay, so what I'm going to do is I'm going to use this first formula here. Okay, and I'm going to first identify what's the first term, how many numbers am I talking about, and what's the common difference each time. So my first term is 1. My common difference is 1. I'm adding 1 each time, and I'm doing it for 100 terms. Okay, so that's what I'm working with here, and I want to find the sum. Okay, so my formula to do this is I'm just going to plug this in. So 100 divided by 2. Okay, 2 times a, so 2 times 1, 2 times 1, because a sub 1, that's just my first term, plus 100 minus 1 times my common difference, which is 1. Okay, a lot of just ones plugging in because that is both your first term and your common difference. All right, so when you plug that all into your calculator, you end up getting 50 times 2 plus 99, which is 5,050. So if you're ever on a trivia show that asks what is the sum of the first 100 numbers, the answer is 5,050. Okay? All right, next one. So like what if it's given you the expression, okay, rather than the first numbers or the sequence, etc. Okay? So find the sum of the first n terms. So I'm going to do the same sort of process here, but I'm going to use this expression right here on the right. And I'm going to end up with an expression because I don't know what n represents. Okay? So here I have, first of all, I'm going to find what is my first term. So when n equals 1. So 4 times 1 plus 2 equals 6. Okay, so my first term will be 6. Okay, so that's what A represents. And n will just be n because I don't know how many terms I'm talking about. So n divided by 2. And then A, which was 6, my first term, plus A sub n. So that's my sequence. 4n plus 2. All right, I'm going to combine some like terms here. So n divided by 2, 4n plus 8. Now really, n divided by 2 is just 1/2 n. Okay, so I'm going to rewrite that just to make it a little simpler. So I end up getting 2n squared plus 4n. Okay, now that might not look like that simple, but let's say then it asked you to find the sum, like let's say you had that sequence and then it said, now find the sum of the first 50 terms. Well, you could just plug 50 then in for n into both of these n's, into 2n squared plus 4n, and you could find the sum of anything. Okay, so now you have a formula for the sum, if that makes sense. Okay, so you could use that formula to find the sum of any number of terms. Okay, we're going to do this one again by hand, this example. You don't need to do it to be able to use it, be able to do it using a graphing calculator. So find the sum of the first 20 terms, okay? So this is one more like the first example when you have a number of terms, okay? So the first thing I'm going to do is find the first term. So 9.5 times 1 plus 2.6, and that ends up equaling, I think that's about 12, 9.5 plus 2.6 is 12.1, yep. All right, and so then we're asking the common difference is 9.5. It's what you're adding every single time. And n equals 20, because that's your number of terms. Okay? So we have 20 divided by 2. Okay? 2 times 12.1. Okay? Plus 20 minus 1. And minus 1 times my common difference, which is 9.5. And when you plug that all into your calculator, and really I would just maybe plug it, if you can get the parentheses straight, you can plug it in all at once. If not, try and break it up into this front and then multiply it by 10. You should get 2047. Okay? Alright, last one. Alright, so we have a ceramic tile floor is designed in the shape of a trapezoid, 20 feet wide at the base and 10 feet wide at the top. So this is figure 13. Okay? Also, I got confused when I looked at this at first. The blue ones are also tiles. Okay, so I thought that it was just the brown ones, but it's all of them. So the tiles 12 inches by 12 inches are to be placed so that each successive row contains one tile less than the preceding row. How many tiles will be required? So it's 10 feet at the top and 20 feet at the bottom, and they're 12 inches by 12 inches, so they're 1 feet each. So how many tiles? So there's going to be 10 tiles here, okay, and then 11 tiles here, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12, 13, 14, 15, 16, 17, 18, 19, and 20. Okay, So we can do this a couple of different ways. So one way, I mean, if it's that short, I honestly would just type in your calculator 10 plus 11 plus all the way to 20, okay? And you should end up getting 165 tiles. Okay. Another way we could do it is we could do it very similarly to the first example we did where we're adding 1 each time, okay? But this time, so my first number is 10. I'm adding 1 each time, okay? And then I'm going to n equals 10, okay? So right here, so your expression would look like something like n plus 1. So you could also write an expression very similarly to what you did in the very first example with adding 1 each time, and you would get the same answer as 165 tiles. But again, I would go ahead, if you have something that short, I wouldn't try and write it out. I would go ahead and I would just add them all up like that, okay? So that gives you, this is kind of a common question of like there's tiles or there's rows of seats in a movie theater, but that kind of gives you an idea of how to kind of deal with arithmetic sequences. In the next video we'll talk about geometric sequences, and that's all.